KGB Maths Dutch.
Okay, students, today we shall be learning class 9 exercise 6.2 question number 6. Okay, so here let us see the question, what it is given to us here in figure. So in this figure, okay, PQ and RS are two mirrors. What they are saying, PQ and RS are two mirrors. Okay, it is given to mirrors. You know what is mirror. So, and placed parallel to each other, and these two mirror PQ, this PQ and RS mirror are placed parallel, it is said. Okay, it is given to us parallel. Okay, these two lines are now parallel to us. So again, what it is given, an incident ray AB strikes the mirror PQ at B. That means one ray, one light ray, that means it is coming from A and it is striking to the mirror PQ at point B. Okay, it's coming and touching them in this line. Okay, and it is reflecting back again. It is saying, and again, what it is given, the reflected ray, and it is coming back again, reflecting back again, and this reflected ray moves along the part BC. That means this BC is the reflected ray. Okay, and strikes the mirror at C, and it is coming and striking at the mirror RS. Here it is given. Okay, then strike the mirror at C, then at point C. Okay, to this RS mirror, they're coming and touching here, and again it is going back again. Okay, it is going back again, you can say like this, it is going back again, and again reflects back, and again after touching the mirror it is reflecting back again. Okay, the question is saying that it's reflecting back along CD. That means this CD line, okay, the ray is reflecting back again, they are saying. So now they are asking us what? Prove that AB is parallel to CD. So now you have to prove that this AB line, okay, this ray is parallel to this CD ray. Now we have to prove this. So here, if you will draw the diagram separately, we will get like this, something like this type. Here A, B, C and D. Okay, so we have to prove that this line AB, okay, this line is parallel to this line. We have to prove now. Okay, so we know if we have to prove two lines, any one transversal is there, we know that we have to prove that their alternate angles are equal. If we can prove, then we can say that these two lines are parallel to each other. It's not it, but here till now AB is parallel to CD is not given to us. Okay, so we will have to prove that AB is parallel to CD. And how we can prove that is, if we can show this angle and these angles are equal, and if these two angles are equal, then we know these two angles are alternate angle also. So therefore we can say AB is parallel to CD. So let's say how to prove now these two angles. Okay, that means this angle and this angle. Okay, how to prove now this angle and these two angles are equal to each other. Okay, if we can prove these two angles are equal, then we can say these two are an alternate angle also. So they are this AB is parallel to CD, we can say. But how to prove that these two angles are equal now? Let us, okay, let's solve now. Solution. So here it is given to us already in the question that PQ, this mirror PQ line, and RS line, okay, this line up to here, and this line is parallel already. See, PQ and RS are two mirrors. These two lines are mirrors, it is saying, and placed parallel to each other, and these two are parallel to each other. It is given already. So here what you will have to know is, if two lines are given to us parallel, then what we can say is, if we have one common transversal, then the alternate angles are equal, everything are equal. And one very important concept what you will have to know is, see here, if suppose two lines are given to us parallel, okay, suppose PQ and RS are two lines, these two lines are given to us parallel, and you see here like this diagram is like this, am I right? A, B, C and D. Suppose this is given to us. So here now I have to prove that this angle and this angle is equal. So here what I have to do is, I need one construction. Okay, one construction. So that will help us prove very easy. So now let us see here, what I am going to do is, if two lines parallels are there, I will draw one perpendicular line here like this. Okay, perpendicular line, suppose BL I am taking here, and from here to here also, from this RS line also I'll draw one perpendicular like this, CM, suppose like this. Do you understand? So when I take like this, what happens here is one very important thing, that is, if two parallel lines are there, if I'll draw perpendicular from this side one and from this side one, okay, then what happens here is this line is also parallel to this line now. Okay, always we have to remember, if two parallel lines are given and if I will draw two perpendicular lines, okay, from each parallel lines, okay, then what happens, that perpendicular lines are also parallel to each other. We should understand this one very nicely. So here what I'm going to do, I'm going to take that construction here. The way we have construct here, I'm going to take that construction here, so that it will become very easy for me to solve this question. Okay, so let us construct. So what I'm going to take here, let us draw the construction here. So from B, point B, okay, from point B, that is to PQ mirror, what I'm going to do, one perpendicular line I'm going to draw here. See, up to B, say suppose L. Okay, I'm taking one perpendicular line. So let us explain, and again from C also I'm going to take one perpendicular line to RS. Okay, you can see up to let me take this as L is already there, so let me take this as M, suppose. So now let us write the construction first. So construction, so let us explain. So what we have taken, BL perpendicular to PQ I have drawn, am I right? So let us say draw BL, this BL line perpendicular to whom? PQ. So let us write perpendicular to PQ. And again what I have done, CM also perpendicular to RS is taken. So N, let me write N, CM is also, that means this line CM is perpendicular to whom? RS. Okay, CM is also perpendicular to RS I have taken, and it is already given to us that PQ is parallel to RS, am I right? So if PQ is parallel to RS given to us, and from PQ line I have drawn one perpendicular, and from RS line also I have drawn one perpendicular line, that means BL is also perpendicular to CM, I can say, because PQ is perpendicular to RS is given to us. Okay, so let us do now. Therefore what I'm going to get here now, I have taken BL perpendicular to PQ line and CM is perpendicular to RS line. PQ and RS, these perpendicular lines are drawn, construction is done. Then what I know, BL is also perpendicular to now CM. So we have to explain the reason, that is because PQ is also parallel to RS is given to us in the question. Okay, so let us write, therefore what we can say, BL is also parallel to CM. This BL is parallel to CM. So why we can say these two lines are now parallel, the two construction lines are parallel, because PQ is parallel to RS. Okay, that is, let us explain, that is PQ, this line is parallel to RS. PQ is parallel to RS, and so we can give, this is the reason, PQ is parallel to RS. Okay, and now let us be very careful here. So whenever we have a mirror, and if light is coming to that mirror, we say what, incident ray, and the reflection, what it is going back, the reflected ray. Okay, we say what, that is reflection. So similar, now you see here we have got one property. Let me tell you, if one light is coming and touching in this mirror, okay, what happens, in what angle this is coming and touching here, in that angle only, exactly equal to this angle and this angle only, the light will go back. Okay, so here also the same thing will form. What angle here? So here also the same angle will be forming. Okay, so we have to know this property. So what we said, this property is angle of incidence is equal to angle of reflection. Okay, so now let us write here, Then what we can say here, you see here, since I have drawn one perpendicular line, so angle of incident, how much it is coming back, that much it is going also. Am I right? So we will use it this one later on. So before that, now let us see. So let us see here, if we see these two lines are parallel, then this BC is one transversal or not? See here, let us draw BL is parallel to CM. We have got like this, so these two lines are parallel to each other, am I right? And here one transversal is there. See, BC, if we see like this, am I right? Let us say this way. They say BL is parallel to CM, because we have got already BL is parallel to CM here. So BL is parallel to CM and BC is the transversal, am I right? So now if I have got already this line and this line is parallel to each other, then what I will get here, I can say that this angle and this angle is equal, because I have already proved that BL is parallel to CM here, am I right? Then I can say what angle LBC, this angle is equal to MCB, this angle, am I right? Then I can say this angle is equal to this angle, am I right? When we look like this, see, this line is parallel to this line, then this is the transversal, then this angle is equal to this angle. We can say this very clearly, because they are alternate interior angles. Okay, so let us write down this one. So then what we can say, LBC, I mean, what we can get, an angle LBC is equal to angle, this angle LBC, this angle is equal to MCB, this angle. Okay, so it is equal to angle MCB. Am I right? Why they are equal? Because they are alternate interior angles. Let us write a region. Alternate interior angles. Okay, interior angles. So let me give this property as number 1. Suppose say this equation is equal to number 1. So again what we have here, ABL, this angle also is equal to angle LBC. I can say, why I can say this two are equal, that is angle of incident is equal to angle of reflection. We know this. Okay, you'll have to remember always angle of incident is equal to angle of reflection, then only we can solve this very easily. So now let us explain that one also. Here we have got angle of incident, coming angle, this angle is equal to this angle out, going out. Okay, so let us write again what we can write, angle ABL. ABL is also equal to angle LBC. LBC we can say. We have to write the region here, that is angle of incident. No, angle of incident, angle of incident is equal to angle of reflection. Okay, angle of incident is equal to angle of reflection, that is angle of incident, coming ray and going out ray. This is the perpendicular, so this two angle will be equal. Okay, this property is telling us. So let us give this one as equation number 2 here. Okay, so let us do again. So similarly here also we can see, for this mirror, this ray is incident and this is the reflection going out. This is coming in and this is going out. Am I right? For the mirror RS. Okay, so let us write here also the same property will form. I mean, this angle is also equal to this angle. Am I right? So let us write again. So again here also what I am going to get, angle MCB, this angle. Am I right? MCB, this angle, angle MCB, this angle is also equal to angle MCB is also equal to DCM. or MCD. Okay, MCD or DCM, you can say anyone else. So let us write MCD. MCD. Okay, this angle. So same reason is this one itself. It is angle of incident. Incident is equal to angle of reflection. Okay, angle of incidence is equal to angle of reflection. So this one let me give us equation number 3. So when we compare this 1, 2 and 3, see question 1, 2 and 3. From this 1, 2 and 3, what we get here, you can take it very nicely here. Okay, so let us see here. Therefore, from 1, 2 and 3, so we have, so what we are going to have here, so let us check what we are going to have here very nicely. Okay, let me explain you. So now let us check here. Let me tell you here what we have got in number 1, angle LBC equal to angle MCB. This is 1. Then in number 2, what we have got, ABL is equal to LBC. Here also angle ABL is also equal to angle LBC. And in equation number 3, what we have got, MCB. So here angle MCB is equal to, what we can say, angle MCD. Angle MCD we have got. So let us see here what we can get from this 1, 2 and 3. Let's check it out. So here LBC is here in the right side. So here left hand side also, then these two can be cancel out. Okay, these two is cancelled. Then again what we can see, MCB is also there. Then MCB also cancelled. So what is remaining, angle ABL is equal to angle MCD. Only these two angles are remaining. So what we can get from 1, 2 and 3, ABL is equal to MCD we are having here. Okay, I think this is clear now. From 1, 2 and 3, from equation number 1, from here, here and here, when we compare these three, what we have got here, ABL is equal to MCD. So from 1, 2 and 3, what we have got here, we can write here angle, what we can say, ABL. Am I right? Angle ABL is equal to angle MCD. What we have got, MCD. Okay, so this one let us give is equation number 4. So now we need equation number 4 and 1. If we compare 1 and 4, so compare means what I'm going to say, if we add 1 and 4, okay, see LBC with this LBC, this angle, if we are going to add angle, then angle ABL, so we are going to get complete this one. Alright, so and again if we will add this angle and this angle to the right side, MCB, okay, MCB, that is this angle, okay, plus this side one, right side, angle MCD, this side one, I will get complete angle this one. Then what I can say, and these two angles will be equal, and also I can say they are lying in alternate angle, so therefore AB is parallel to CD. I can give my confirm answer. Okay, so let us write it down this one very nicely. Let me explain here. Now from 1 and 4, okay, that means I will add now let us add equation number 1 and 4 so that we can get our required answer. 1 and 4. So now let us do, now adding 1 and 4. If we add 1 and 4, so what we are going to have, equation number 1 and equation number 4. If we add, what we are having here, we know left hand side we need to add in the left hand side, right hand side we have to add in right hand side. So what we are having in 1, so let us see, angle LBC, am I right? Angle LBC plus left hand side one, equation number 4, left hand side, angle ABL, so angle ABL. So this will be equal to, am I right? After this there is equal to. So left hand side equation number 1, MCB, angle MCB plus which angle here? Angle MCD. So let me write here angle MCD. Okay, so now what we are going to have when we check out this one? So let us check out angle LBC. Which one? LBC. That is talking about this angle. This angle, am I right? This angle plus angle ABL. Where is ABL? ABL. That means this angle. Am I right? ABL. That means this angle plus this angle. What we are going to have? Angle ABC. We are going to have all total angle, that is ABC. So when we add these two, we are getting angle ABC. Am I right? And also this is equal to what we are having now. This side one, let us add it, MCB. What we are going to have here? MCB. That means this angle. Am I right? MCB, MC and B. Plus what we are having, this angle plus MCD. MCD, that means this angle, am I right? That means this angle plus this angle. That means what we are going to have, this angle plus this angle, we are going to have BCD. Am I right? We are going to have here angle BCD. That means we have got already this angle and this angle is what? Equal to each other. Am I right? So now when we are observing very nicely, we have got that this angle and this angle is alternate angle also. Am I right? This angle, hold this angle and hold this angle is alternate angle also. So therefore what I can say now, AB is parallel to CD. But we have to explain that these two angles are equal. We have got already, so they are lying in alternate angle or places also. Okay, then we can say that AB is parallel to CD. So let us write it down. So also what we can say, these two angle lies in alternate place. Am I right? So also angle ABC and angle BCD are alternate angles. Let us explain. Also angle ABC and angle BCD are alternate angles. Alternate angles. Am I right? So therefore now we can say, that is what, therefore what we can say now, AB, this AB line is parallel to CD. Therefore AB is parallel to CD. We can say confirm. Okay, so we have got our proof. So this is the calculation how we have to solve this question. So I think you have understood.